In this lecture, you're going to learn about the final layer in the OSI model, which is layer 1, the physical layer. OSI layer 1 conveys the bit stream, meaning it puts the actual bits onto the wire. That could be electrical impulse over copper cables, or light over fiber optic cables, or radio signals over wireless. So it does that, and it takes control of the network at the electrical and mechanical level. It provides the hardware means of sending and receiving data, including defining the cables that will be used, the interface cards and the Ethernet ports or the WAN port types in there, and the physical aspects of the network. In this lecture, just like in the last one, we're going to focus on the local area network, so we're going to be focusing on Ethernet again. Again, we're going to cover wide area networking in a later section. Our Ethernet LAN connections can be carried over coaxial cable, which was the original implementation, but that's not used anymore. What we have nowadays are twisted copper pair cable, or fiber optic, or wireless. Starting off with our copper cables. So we use UTP cables for this, unshielded twisted pair. They are commonly used to connect desktop computers to switches. The connector type is RJ45, and the maximum length of the cable is 100 meters. And if you have a look at the picture on the slide here, I'm sure you've seen a standard network cable before. This is the copper cables we're talking about here. A standard network cable is an RJ45 connector at the end. Let's have a look at the link I've got on this slide as well to get some more information on UTP cables. So the link is on Wikipedia, and you can see with our standard UTP cables, we've gone through several different iterations. Cat5 was pretty popular not that long ago. We're up to Cat7 now, and Cat8 is in development. The difference between the cats is the categories. The difference between the categories, well, newer categories have got support for higher bandwidth connections. Back when Category 5 first came out, we didn't have 10 gigabit, 40 gigabit, or 100 gigabit Ethernet back then, so Category 5 was fine for carrying the maximum bandwidth connections that were available then. And you still will find some offices that have got Cat5 cable in there. If you want to carry 10 gigabit Ethernet, then the minimum is Cat6 cable. So Cat5 and Cat5e can go up to gigabit Ethernet. Cat6 supports 10 gigabit Ethernet. For the newer standards, which are 40 gigabit and 100 gigabit Ethernet, now I say they're standards because they're standardized, but they're not really in all that common implementation yet. They haven't been out for all that long. You'll find in a lot of enterprises now they go up to 10 gigabit Ethernet, but 40 gigabit Ethernet and 100 gigabit Ethernet is going to see more common deployment as time goes on. Okay, so those are the different category of cables. And the next thing to tell you about is that the copper cables, they can be either straight through or crossover UTP cables. The receive and transmit wires can be wired to the RJ45 connector as either straight through or crossover. If I go back a slide, you see on the end of the cable there, that's the RJ45 connector, and there's individual receive and transmit wires in there. They can be cabled either straight through, is more common, or the wires can be reversed, which makes it a crossover cable. Straight through cables are used to connect an end device like a PC or a router to a switch, so they're more commonly used. Crossover cables are used to connect devices together directly. They're most often used to connect two devices of the same type. For example, two computers to each other or two switches to each other. Cabling two computers to each other is not a normal thing to do. It's not a very big network if you've only got 2 computers there. So if you were in a pinch and you needed to copy some files from one computer to another and you had no other way of doing it, you could connect them back to back with a crossover cable and you could transfer the files that way. But we've got things like USB sticks nowadays, and in a normal office we'll have a switch there that we could connect them through. So it's very rare you would ever consider connecting computers back to back with each other like that. What is common though is connecting your switches to each other. Say we've got our building at work, we've got the bottom floor, and everybody on the bottom floor is connected to our bottom floor switch. And then we've got the first floor, and everybody on the first floor is going to be connected to our first floor switch. Well, we want our staff on both floors to be able to communicate with each other on their computers, so we're going to need to connect the switches together as well. The standard way to connect 2 switches together is using a crossover cable. However, modern switches support auto MDIX, where the receive and transmit signals are reconfigured automatically to get the expected result. So with modern switches, you don't have to use a crossover cable. You can use a straight through cable as well, and that will still work. So the normal way to do it is a crossover, but really modern switches, a straight through will work just fine as well. But if you are going to use a straight through, do check that it does support auto MDIX. Okay, so that was our copper cables. Moving on to fiber. Fiber supports longer distances and higher bandwidth than is possible with copper. Kind of places where you use fiber cable would be if you're connecting between 2 separate buildings within the same campus. So again, we're still talking about the local area network here. So all of our PCs in the local area network are going to be in the same building or within the same campus at most. When we are in a campus kind of environment, like maybe a university, and we want to cable our buildings together, typically the connections between switches in different buildings will use fiber optic cables. Another reason for using fiber is for those switch-to-switch connections inside a building, because we'll typically require higher bandwidth between direct connections between switches in the building, and copper might not be able to cut it. With fiber, we've got 2 different types. There's single mode and multi-mode fiber. Single mode supports higher bandwidth and longer distances than multi-mode, but it's more expensive. Let's have a look at the link here now. And I've got this on my second tab. So this is the Wikipedia page for multi-mode fiber. And you can see, just like we had the different categories were released over time for copper cable, there's different standards for our fiber cable as well. This is on multi-mode. So you can see for 10 gigabit Ethernet, depending on the type of cable we're using, it can go up to 400 meters. 140 gigabit Ethernet are supported on fiber as well. They're not supported on copper yet, and that can go up to 150 meters. So looking at multi-mode fiber, you're looking at a maximum length of a few hundred meters. Single mode can go much further. It can go up to several hundreds of kilometers, again depending on the cabling type and the other physical hardware you're using. So our last slide here, this is a picture of some of the different fiber connectors that are available. There's lots of different types of fiber connectors. Depending on the type of cable you're using, whether it's multi-mode or single mode, the kind of distance it's going over as well, there's going to be different connectors there. Another difference between fiber and copper is that the copper RJ45 connector will plug directly into the switch, but fiber connectors, they'll normally go into a transceiver, which then goes into the switch. So you've got the switch with an open port in it, a small transceiver goes into the port on the switch. You choose the correct type of transceiver that matches the connector and the type of cabling that you're using. There is one last thing that I want to tell you about here, and that is PoE, Power over Ethernet, which you can use as a convenient way to get power down to your PoE capable devices, such as IP phones and wireless access points. So you can see in the slide here, we've got an office and they've got IP phones on their desks, and they're also using wireless access points as well. And the traditional way to have those on the network is that they would all be connected into a standard switch. And if you're using a standard switch, meaning it does not support power over Ethernet, then you're going to need to have power supplies plugged into all of your devices as well. So if there's, say, 100 IP phones on the desks there, then every single one of those IP phones is going to have a network cable plugging it into the switch for the network connectivity, and it's also going to have a power supply plugged in as well, plugged into a wall socket. But there is a more convenient way that we can do this, and that is using a PoE power over Ethernet switch. They look the same as standard switches, but they have the added PoE functionality. When you use a PoE switch, the power is sent down to the device over the standard network cable. So that saves you having to use a separate power supply for all of those different devices. So in our example, in the office with the 100 IP phones, then that is 100 phones now that are not having a power supply plugged into the wall port. So there's less cabling. It's just a whole lot more convenient for your users as well. So when you do have an office which has got IP phones deployed in there, it is most often used that you're going to have a PoE switch there rather than standard switches. Another thing that you'll sometimes see with PoE, but not as commonly, is if you're not using IP phones, but you do have just wireless access points there. Well, if you've got a wireless access point which is in a location where it's hard to get power to. For example, maybe it's in the roof in a warehouse and there's no power points near there. And then what you can do is you can use a power injector. So rather than putting in an entire power over Ethernet switch, if you've already got a standard switch in there, what you can do is buy a power injector. The power injector gets plugged into power, and then it supplies power over Ethernet over the Ethernet cable towards the wireless access point. That Ethernet cable can go up to 100 meters, so it's a way that you can get power to a wireless access point in a location that it would be normally difficult to get power to. Thanks for watching. If you want to get hands-on practice with Cisco networks for free, then you can download my 400-page CCNA Lab Guide, which you can see above my head right now. Also, check out the video about my CCNA course. It's the highest rated course online. Thanks.